Okay, here we go. Still talking about normal distribution, the normal distribution, and looking at now using our calculator, our Tinspire, to solve some problems with it. So we have an example 2 here from your textbook. So this is 24B. Example 2 says x is distributed normally with 10 2.3 squared. So remember 10 means the mean, that first number. Okay, that's the mean. And the next number is the variance, but that means that the standard deviation is 2.3. Okay, because so those numbers will help us with our calculations. Okay, so it's distributed normally. So we want to think about the normal distribution curve. Let's take a look back here, what we looked at last video with these percentages in the normal distribution curve. Okay, so we've got these percentages. So this works, these memorized percentages in these areas above and below, with standard deviations above and below the mean. They work if we're looking at these exact distances. So in between any of these exact distances. If we want anything else in between, say we want something that's the mean plus 0.3, and we don't know what the standard deviation is, then we're going to need another means of doing that, and the Tinspire calculator can help us with that. Okay, so for example, if we're looking at probability between 8 and 11. So let's take a look at what this curve would look like, because we have to illustrate it anyway. So again, normal distribution, we have the mean of 10, standard deviation of 2.3. So if we think about one standard deviation above, then that's going to be 12.3. Another standard deviation above, add 2.3 again, so 14.6, and so on. Go back the other way, subtract 2.3, so 7.7. Subtract another 2.3, so 5.4, and so on. Okay. Now this is asking for probability between 8 and 11. So we're actually looking for a little bit after that one standard deviation below, and we're looking at part way up here in between the mean and one standard deviation above. This is actually the area we're trying to calculate here. Now, since it's not one of our nice, neat, even points, 7.7, 10, 12.3, then we're not going to be able to do that just from our head and memorizing those percentages. We have to be able to use our calculator. So this is what we do. Keystrokes are, so for the Tinspire, keystrokes are menu, probability, distributions, and then normal CDF. Normal cumulative distribution function. They're going to ask us for the lower bound. So I'm just going to do all this now. Menu, probability, distributions, normal CDF. You'll notice that there's also a normal PDF. Do not choose the normal PDF. We're only going to be using normal CDF. So choose that, and this pop-up screen appears. We need to put in our lower bound, and in this case, our lower bound, we're looking for the probability between 8 and 11. So our lower bound is 8, so put 8 in there. Upper bound is 11, because it's equal to 11 as well. And then we put in the mean, 10, and the standard deviation, 2.3, and press OK, and it gives us our result. So the result for this one is 0.476. That would be the probability. So almost 48% of the data lies within there. Okay, next one. Probability that x is less than or equal to 12. So do these same keystrokes again. Menu, probability, statistics, normal CDF. Lower bound this time. Okay, let's think about lower bound. You'll notice that already it's entered in here, negative 9.99, no, negative 9E999. That actually means negative 9 times 10 to the exponent of 999. Okay, so a really far negative number. So we're assuming basically negative infinity. That's That's representing negative infinity. So you can leave that in there because that actually is going to be our lower bound. We don't know what the numbers are, but theoretically this goes on forever in that direction. So we're going to leave that there. Upper bound though is 12. Is it equal to 12 as well as less than? Yes, it's equal to. So our upper bound is 12. Our mean stays at 10. Standard deviation 2.3 plus press OK again. And we get 0.808. So that's the percentage of data. Now, we have to illustrate this. Let's make sure it makes sense. Okay, and when you illustrate it, you don't necessarily have to put all of these values on here every time, but you should definitely have your mean on there. The mean is 10. And we were looking for anything 12 or below. So does this big value, bigger than a half, does that make sense? 12, let's put 12 here. And we're actually looking at all of this area. So yes, that makes sense. It's more than half because up to the mean would be half, and it's more than half. It's not quite another standard deviation up, so it wouldn't be 50 plus the 34, which would be 84%. So it's in a good place. So be critical of your answers based on those percentages that you do know back there. Okay. All right. So third one. Probability that x is greater than 9. Okay, this time it's not equal to 9. It's only greater than 9. Okay, so greater than 9. But let's think about that. We have to go menu. So menu, probability, distribution, normal, CDF. Okay, our lower bound though. So if we think back to thinking about the area under a curve and calculus, if we want to calculate the probability that x equals 9, we're actually not going to be able to do that because it's such a small strip that it has an area of 0 actually. Okay, so the probability that x equals 9, it'll give us 0. Okay, so we can't do that. The probability that x is greater than 9 and the probability that x is greater than or equal to 9 then is therefore going to be exactly the same thing because of the fact that we can't find it equal to 9. Okay, if we tried to find the probability that x is equal to 9, we would end up having 0 because that strip is too small for it to have any size to it, any area. So in fact, in the normal distribution curve, it is true that these two things would actually be equal. Okay, and the reason is because we can't find the area of one strip. Okay, so let's do this. Our calculator. So our lower bound is going to still be 9. So lower bound this time is 9. Upper bound then is what? Okay, anything bigger than 9. So if I'm going to illustrate this guy, anything bigger than 9. I know my mean is still at 10. Okay. Do a better job at that. My mean is 10. And I'm looking for anything bigger than 9. So 9 is less than 10. We all know this. So that's going to be on this side. And it's going to be everything here. So we know it should be bigger than 50%, shouldn't it? It should be bigger than 0.5. All right. But the question is, what do we use for our upper bound? Basically infinity. So you want to mimic what was in there before with the negative 9e999. So you could say 9 positive 9 times 10 to the power of 999. And we need the mean still at 10, standard deviation still at 2.3, press OK. And we get 0.668. 0.668. 0.668. So those are the values. Those are the illustrated representations of those values. Just check it in the textbook, make sure we got all the same answers, and yes, we do. There we have it.